All right. Bright lights. I love it. If you want to come in, I'm sure they're going to turn me down a little bit, but if you want to stay in the back, go ahead. So thank you for joining me. I really appreciate it. I know it's the end of the day. Everybody's a little bit probably running out of energy or whatnot. Everybody have a good time? Have some good talks? Right on. Anybody have a hamburger? Had to come all the way Croatia, get this massive hamburger. It's awesome, very Texan, like it. So thank you again. So I'm going to be talking today about two fundamental principles of software engineering, cohesion and coupling. And come on, clicker. Of course. Let's do this. So again, I'm Peter, Director of Engineering, not anymore, advocacy, but I have about 25 years experience, over 25 years experience, software engineering. I've been in multiple roles across the org from, typing away at the keyboard to running teams. I really enjoy teaching and speaking and mentoring, so now I run developer relation teams. There we go. Come on now. Okay, so what's the problem? Why are we going to talk about cohesion and coupling? So software is very hard. What we do is hard, right? Writing software is hard. We're gonna drop that. Writing software is very hard, right? What we do day to day is extremely hard. It's mentally taxing, right? Complicated, and we're under massive time crunches, right? When I was an engineering manager, my bosses and their bosses would always come to me and say, how do we get faster, right? How do we increase velocity? How do we get more story points, right? You write down the story points and you see how many story points, and we track that, right? Horrible indicator of how good your engineering teams are doing. Horrible indicator of how well they're delivering code, right? If you're an engineering manager in here, drop that. All you Scrum Masters, I'm gonna beat you up in a minute. So we do Agile, right? No, we don't do Agile, right? Agile is not an SDLC. It's not a software development lifecycle, right? It came from the Agile Manifesto, which is a set of principles that a bunch of engineers got together and said, we should build software this way, right? We should be closer to our customers. We should work face to face. Anybody here do Agile? Say, we do Agile, right? Yeah, anybody remote on your team? You're remote? Yeah. So Agile, technically, is everybody's remote. Face to face is better. You go, right? So we don't even do Agile, right? We mostly do Scrum these days, right? And Scrum came from a manufacturing process, right? So when they were building cars, they would work cross-functionally. They would look at their processes every day. How's the car being built? What problems did you have yesterday? Let's fix them, right? That's not how we build software, right? And we're going to talk about a little bit how we write code and how cohesion and coupling fits into that. So our SDLCs are kind of messed up nowadays, right? We take these big rocks or boulders, if you will, and you break them down and you create user stories, then we put points on them, and then we start writing code, right? And again, push, push, push. What'd you do yesterday? What'd you do today? Any blockers, right? Getting these stand-ups. If you're doing stand-ups, I would have you consider not do stand-ups, right? You don't hire smart folks like yourself and then micromanage them, right? That's another talk for another day. So we make compromises, right? And that produces technical debt. You can see here the three-legged chair, right? You have time, quality, and cost, right? If you want to reduce time and have more velocity, well, probably your quality is going to go down, right? You can address that maybe with more money, bring more engineers in, more resources, right? But then your quality starts to go down, right? Your communication goes down. So it's a three-legged stool that we kind of play with in just about everything, but mostly in software engineering, what I'm talking about. And so then systems get old. We collect technical debt, right? And when I say technical debt, it's a byproduct of some of the processes we do, in my opinion, right? We write code very fast. We don't plan. We don't step back. We don't architect our systems largely, right? And if we do, we're doing it while as we're writing code. So then we have leaky abstractions. We have tightly coupled code, all these different things, right? And so that leads to monolithic code, right? And yes, there's monoliths, right? And those are fine, right? If you're building a monolith, you have a small team, you're getting started, build your monolith, right? That's how I've been doing this for almost 30 years, right? That's how we built code all the time, right? Apps all the time. Front end, middle tier, database, right? Go for it. Scale horizontally. all this good stuff. So my suggestion is start with a monolithic code and then start breaking it out, right? Using some of these concepts apply to that. And so now we have these large code bases, whether we try to or not. They become brittle, even with testing, right? I have another talk on testing. I love it because, right, it's kind of an internal talk to engineers, right? Of course you should test, right? Of course you should write integration tests. But, you know, we should think a little deeply about how much testing we're actually doing and how productive they are, right? Are we just writing unit tests or tests to test our mocked up data, right? I don't know how many times I come into teams and I see 80% of their testing is just done on mock data, right? It's a waste of time. Not testing, don't beat me up, don't put in the comments, Peter said don't test. Absolutely test your code, but think about it, right? So then things become hard to update and hard to deploy, right? And so I want to couch this conversation around cohesion and coupling in refactoring. Anybody have heard of refactoring, of course, right? Yeah, so Martin Fowler, I don't know if he coined the term, but he's pretty famous. If you don't know who Martin Fowler is, go check him out. He's, writes a lot about software engineering practices and principles. They're very ivory tower, right? So academic, right? But you can bring those down and make them your own, right? So go read his stuff. But refactoring is a process of changing a software system in such a way that it does not alter the external behavior of the code, but yet improves the internal structure, right? And we're going to talk about that in a second. So you can read this for yourself, but the main point of this is the key insight is that refactoring and adding features and functionality and bug fixes are separate things, right? We'll pause for the applause. All right. They're two different things. They're two different modes of how you work, right? Now, a lot of times, new features or bug fixes is what triggers you to start to refactor, right? You jump into a code base, you go, oh shit, what is this, right? You hit the blame button, blame it in, oh, that was me. That's happened multiple times in my career, right? And so we dive into the code and we start looking at it, it's a jumbled mess, right? So we start trying to refactor as we're writing functionality. So we're changing the external behavior of the application while refactoring, right? It's like, I don't know, driving with a blindfold on. That's a horrible analogy, but you get the idea, right? You're trying to do two separate things at once. Now, you senior engineers in here, staff, principal, I'm sure you're in here, right? You do that a lot better, right? As you move up the engineering stack, you get better at writing code, you get better at fixing bugs at the same time, you get better at adding features and refactoring at the same time, right? You start to put everything in your head, and you're able to reason about it a little bit different. And then you just have years of experience, right? Which is wisdom in my mind, right? You go from knowledge to wisdom. So refactoring is the idea of cleaning up my code, getting better interfaces, getting better separations of concerns, getting better cohesion and coupling. Okay, so let's talk a little bit about how we write code. Woo, I'm going fast. Okay, so how we write code. So there's kind of two phases that we write code in. It's the same as anybody go to university and have to write papers, right? Right, so you write a paper. Of course, we probably all cram to the end. But there's kind of two phases when you write a paper or any kind of mental work, in my opinion. There's a top-down approach, right, where you're focused on your task, you're getting things done. And then there's an editing phase, right? And so we do the same with code. Whether you realize it or not, this is what we do. And it might be micro switches, right? When you're a junior programmer, it takes, it's bigger chunks. You're writing code, top to bottom. You get it to work. You focus more on getting working code, right? Anybody practice these coding exercises for interviews, right? Sorting functions and transversing trees and all these type of things, right? The idea is get your code to work and then refactor it to make it quicker or improve it, right? Two different things. So what we do day to day and mostly in our jobs is we turn logic and reason that's captured in business requirements and we convert them to code, right? If we had to boil down what we do as software engineers, that's what we do, right? There's a whole bunch of other things and there's a lot more contained in that. But generally speaking, that is what we do. We take reason and logic and we turn it into these abstract things, and we turn them into concrete things in if-then statements in our code, all right? So the idea is, in your coding phase, produce working code, but it's not necessarily maintainable, right? You're repeating yourself, you're writing bad code, you're not optimizing it, you're copying, pasting code, those type of things. So copy and pasting is not bad, as long as you know what you're doing. If you're a junior person, you're on Stack Overflow and you're copying and pasting, shame on you. No, I've done it. Believe me, I've done it all the time. And then that second phase is we start editing, right? You take a step back and you start looking at your code. You're looking for patterns across that code. You're looking for reuse and ability to genericize your code. I don't know who coined that term. I heard that term many years ago, genericize, right? I don't even know if it's a word, but the idea is you start looking at your code, where are the commonalities at? So for example, and I'll give you a very, very simple example, not very complicated, just so we can talk about it a little bit. Let's say I have an application and I need to format a telephone number, right? So when I'm in the coding phase and I'm first writing this, I'm gonna write top to down, and I'm writing some business logic, and then I go, oh, I need to format a phone number. Okay, well, let me just write it in line, right? Day or two later, maybe next week, you start writing some other code. Maybe you're doing a report, right? And you have to print out that phone number. So it's only 3 lines of code. You copy and paste it, you stick it in there, right? And next thing you know, you have it all over the place in your code. And then, so what you should do is find, hey, same functionality, let's pull this out, let's put it into a function, right? And now let's pass in the string. If you're putting your phone numbers as integers, who are you? You storing phone numbers as integers or longs? Don't, please. Was that a hand raise or a head scratch? That's a head scratch, okay. And if you were, hey, use the numbers, I don't care. But, right, phone numbers are not numbers, right? We're not adding and subtracting them, right? You're not multiplying them. They're just lithographs that denote the numbers you push on this device to talk to someone, right? So that's my counter argument. But so you see this code all over the place. You create a function, you pass in a string, we format, return it, right? So now you go back and you refactor. Let's take these pieces of code, let's replace them with a function, cleans up our code, right? Separates things. And so later on, when, let's say I'm an American company, right? And we do our phone numbers different than Croatia. And now I have to change the logic of how I format telephone numbers, right? And so now that I've refactored it out and I put it into a function, I have one place to change that, right? Don't have to change it throughout my code. Has everybody done that? I've done it before a million times. Let me go search for all the places where I need to change this bit. And honestly, it's a 1 line of code sometimes that I've changed it 25 places and I left it there. Shame on me, but it's a balance, right? So you should be dogmatic in these things, but be reasonable, right? And so what we're looking for is tightly coupled code that's low cohesive. And we're gonna talk about that. So there's kind of 2 modes of operation. I wanted to kind of back up and, back up my point about coding and editing, right? It looks like there's a lot of senior folks in here, so you do these things very quickly. Coding and editing, refactoring, right? You do them fast, right? But they're actually 2 things. And our brains are set up this way, right? So if you realize that, you can write code a lot better. So it's okay, write top down, write shitty code, right? Then fix it, right? So you have the default mode and the task mode in your brain, two major modes in your brain. The task mode is when you're focused on a task, you actually narrow your vision, your optical nerves and chemicals are released to narrow your vision down. So if you really need to get into flow, right, and write really good code and knock out some code fast, take the 5 monitors that you have, get rid of them, get on your laptop, focus down narrowly, your vision will help you focus, right? And that task mode network will peak up more and you'll get things done quicker. You feel like you've written code forever and you come up, oh, that's hysterical, my phone is playing music. Okay, so that task mode will focus you, right? And it gets you into flow. And when you pop out of it, you're like, oh, wow, it's been 5-6 hours, right? I should go get another Mountain Dew, right? Now the default mode is just that. It's the default mode. It's more abstract. It's what makes those connections, right? I have ADHD, right? Is everybody familiar with ADHD? Thank you. Yeah, attention deficit hyper disorder. I don't have the hyper, even though you'll see me in a social setting. I'm not running around, but I will fidget, right? I'll bounce my foot. And with ADHD is your brain can't control the default mode. So you focus, and then this default mode goes in and goes, oh, hey, the squirrel, right? Oh, hey, are the kids okay? Oh, is the house burning down, right? And it interferes with what you're doing. And this is so I came to some of this, how to focus a little bit. But that default mode is very, very important, right? It's what makes connections into your code, right? You start looking at the forest and not the trees, right? And you start building relationships between your code. You're able to see where I need to make interfaces, where I need to separate things out. That's your default mode. It's your creative making connections, right? And a task mode is that focused task. You need both, right? And so that brings us to cohesion and coupling. So we talked about some of these principles. We talked about refactoring and when to write code and when to fix it. And these two foundational principles underline all of our software patterns, right? So our singletons, every patterns, right? Anybody read the Gang of Four book? It's the patterns book. Yeah, it's a great book. It's a little old. There's some newer books that have kind of take those concepts and put them into your programming language. Don't go crazy on them, but it's what we have in our field of study and field of expertise as engineers do, right? When they build homes or they build bridges, right? We have some known patterns for architecting these things, right? And same with code, right? So we have code patterns that we use. And cohesion and coupling you will find across all of them. Okay, so a bunch of words up here, but coupling and cohesion are the two main principles of good architecture, irrespective of your language or how you program, right? So procedural, functional, object-oriented, doesn't matter, right? These principles lay at the foundation of them. Coupling and cohesion are contrasting. So low coupling often correlates to high cohesion and vice versa. Low coupling is often a sign of well-structured computer systems and good design. When combined with high cohesion, supports the general goals of readability and maintainability, right? Those two last bits there at the end are the most important, right? We don't write code for computers, we write code for us, right? I write code for you, so you can come behind me and understand it, maintain it, add functionality to it, right? Speed and optimization are done at a different level, right? If we were hyper concerned about speed and optimization, we'd still all be programming in C, right, or assembly. We wouldn't be using JavaScript. Not saying JavaScript is slow. Java's slow. JavaScript is not slow. It was just, it was a laugh, thank you, appreciate that. Right, but we write code to be readable and maintainable. Yes, and to create features and functionality, of course, right? But, right, like I mentioned earlier, you always come back in your code bases and you get the WTF, who wrote this, right? And you cry, right? And you're like, ugh, crap, I should have done this better. So focus on these two things. So what coupling is, and you can read this while I talk. So coupling is where two systems or two pieces of code are coupled together, right? How they interface, how they interact. And let me give you a real world example to express this in the physical world, and then we'll jump back to the code. So think about a car battery, right? Car battery has two prongs on, plus and a minus. And that battery is loosely coupled into that engine, right? Like literally, right? You just undo bolts and pull it off, right? Pick that battery up, you take it over to a boat, put it in there, connect them, right? As long as it's the same cranking amps and all that good stuff, but you can connect it, it'll fire up your boat, right? You could take it back out, you put it in a car. I knew a guy in West Virginia. Anybody ever been to West Virginia in the States? Yeah, interesting state. No offense to anybody, but he had a car battery powering his house. He had a stack of them and he wired these all together and he was sending power into his house, right? The battery didn't care. It was loosely coupled and was able to use anywhere, right? It's the degree of interdependence between software modules, right? That's what you're looking at. Cohesion is things that live together should be close together, right? So if we're writing a okay, let's talk about the battery again. So if we have a car battery, inside of that car battery, you have cells. Now, I don't know exactly how batteries work, so I'm going to fake it. I'm going to wing it a little bit here. But so you have cells inside of a battery that have have a chemical reaction that occurs that produces energy, right? And so those are subsystems that are also loosely coupled, highly cohesive, right? And these produce energy within the battery, right? Now, those things are done inside of the battery, right? They sit close to your energy source, and that's all they do. The battery doesn't know anything about boats. It doesn't know anything about cars, right? It only knows how to store energy and to expel that energy, right? That's the only thing it knows how to do. So, and everything that does that is all contained within that battery. It's cohesive, highly cohesive, right? It's the strength of relationships between pieces of functionality within a given module, right? And then inside of that, you should have loosely coupled, highly cohesive pieces of code. And inside of that, right, it's turtles all the way down, okay? So two good examples in my mind of where you can see this out in the wild is your data access layers, right? If they're written well, or you use third-party libraries, all they know how to do is go somewhere, get data, and give it back to you, right? You have a clean interface. Let's talk about relational databases, right? You have SQL, which is your interface into your data, right? And that's all that we have to worry about as engineers. I'm simplifying things, of course, right? You have to worry about performance and the way you structure your relational data and indexes, blah, 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 right? But that's still not at the database level or at the data access layer, right? Those things are done outside of that. So the data access layer only knows how to connect, get your data, give it back to you, right? Update data, say, yep, passed or failed, those type of things. It does one thing and does it well. Same thing within the database, right? The database knows nothing about how your application works or what it's doing, right? All it knows is you give me data through SQL. Those are your interfaces, right? And it knows how to store it, right? Stores it on disk. It stores it on, you could have monkeys in the background writing things down in paper. Who cares? We don't know, right? We're not concerned about that, right? And a database system does that. It knows everything about data. It knows how to performance tune it. It knows how to store it. It knows how to access it, right? Does it write it to disk? Does it put it into memory? When does it shuffle it in and out of memory? Those are all subsystems that are only concerned about that, right? And again, it's cohesion and coupling all the way out. Logging libraries are my favorite, right? Logging libraries. Wow. I've got no applause this talk. Thank you. No. Yay, thank you. All right. Now you're just lying. Now you're just lying. All right. So anybody wrote a logging library? No? Come on now. Don't be shy. I have, right? It's kind of a modern equivalent to me to, I used to be a C programmer, or a C programmer. And everybody, if you ever go back to C and C++, and you come from a higher level language, oh God, it's painful, right? You don't have strings, you don't have you have a standard strings in the standard C++ library, right? But what we used to do is everybody wrote their own string class, right? And then you screwed it up, it was shitty, right? And same thing with logging libraries. I've written my own logging library. In Ronin.js, I have a logging library. I've stripped it pretty much all out, and it just writes the standard out, right? But, because we mess it up, right? It's such a simple thing. All the logging library does, it wants to know what's the message and at what log level you're at, and then it puts it somewhere, right? We're not concerned of whether it puts it to disk, it puts it in a database, and neither should that logging library, right? It should only know I got a message, and now I'm going to give it to another system to put it somewhere, right? The logging library only knows about what levels of logging you have. Now, this is the modern logging. You're probably running containers. You're probably going to dump it to console.log or whatever, right? But the logging library is not concerned about that. You'll see good logging libraries on the market, right? You're able to plug in writers. So log, and then you can plug in a database writer or a file writer and all those type of things, right? And so it's a very simple system, but we get complex with it, right? We're engineers. We like to over-architect things, right? And so I think it's a really good example of leaky abstractions, right? So where do you get your configuration of what level your logging's at? Usually out of a config file that's set somewhere else by the developer, right? And then your logging library knows, oh, I know about this config file. I'm going to pull that out of there inside of my logging library, right? That's called a leaky abstraction, right? So that logging library has to know where it gets its configuration. You have to know. And then you put this into this configuration file that has 50 million things, or it has its own configuration, right? It's a nightmare. What you should be doing is take that logging level and pass it in, configure your logging library with that level, right? And I know the smart ones of you out there are going to say, well, now I'm just going to pass data from data to data configuration all the way down, kind of like React. Does anybody have React, right? You pass all these data down through your components, right? Although it's more painful, I implore you to start that way, right? And then abstract out and use your cohesion and coupling, right? Leaky abstractions are a nightmare. If you work on big, complicated systems at scale, right? So I used to work at Dell Computer Systems. Doesn't impress you, I know, but back in the day, it was the #1 e-commerce site in the world before Amazon, everybody, right? And we used to say, you can test and performance test all you want until you go to production. Once you go to production, the scale that we were selling computers at was crazy back then, even now, and things would just break. So, be very dogmatic on the way you set up your code, right? Clean interfaces, low coupling, highly cohesive, right? And some more things to think about. Start looking at your code, looking for stuff that's been copied and pasted. The dry principle of it, heard of the dry principle, right? Don't repeat yourself, right? Oh, a great article on leaky abstractions is Joel Splotsky. If you go back and read Joel's stuff, right? This was written in 2002, so 20 years ago. Still relevant and applicable today, right? Read that article. It's a great article. If you forget it, hit me up on Twitter or something. I'll show you. He has a bunch of other articles. If you're rewriting, anybody in the midst of doing a massive rewrite, oh, thank God. And you wouldn't admit it anyways because you knew I was going to give you a hard time. But, right, massive rewrites are you should not be doing them, right? It's too hard. You've built up too much functionality over 5, 10, 15 years, right? To try and reproduce that in your code, you're going to miss all the edge cases. It's never going to make it. I've seen it time and time again over 30 years. And think deeply about your separation concerns, right? One of the hardest things in software engineering is naming your variables, right? Setting up your code structure, right? I mean, just your file system, right? It's hard. And the other one is separation of concerns, right? Where are my boundaries, right? Again, it's an abstract term, right? And it covers different kind of things, and how you implement them. You implement them differently, but really think about your boundaries in your code, right? I was contracting at a company. I won't mention their names. They had a 15-year-old application, was making about $6 million a year. They wanted to rewrite it, right? It was in .NET. And so they wanted to rewrite it. They wanted to go serverless. We got to go serverless, right? So when I came in, they had about 250 functions that they had written. 250. They were a nightmare. So they had one project for that, and then they had 2 more projects because they were thinking ahead, right? So they had one project that put that function into AWS. They had another project that did all the GCP bits, right? And I asked them, why are you doing this? Oh, well, because we're concerned if we ever go from AWS to Google, right? You don't do that, right? You never do that. And if you do, those are usually big projects, right? We used to do it back in the day. Well, what if we go to Oracle? We're on SQL Server. What if we go to Oracle? Let's get this big abstraction layer, right? You never do. So don't worry about it. And when you do, you'll have to rewrite the code anyway. So, right, sorry, getting a little bit off topic here. We got 1 minute. All right. So, refactoring path, straight line code, top to bottom, write your code, right? Pound it out, just get it done, get it working, get it functioning, right? And then you're going to move the functions, pull things out, or whatever the equivalent is in your language, put it into functions, then think of classes, and then how do I put those classes together in a module, right? I want those modules to be cohesive. I want everything that's done in that module to be related. If it's not related, put it in a different module, right? And then make your interfaces very, very clean, right? Push your data in. Don't make assumptions within your modules of how things come in, right? Don't look out. You want to be looking in, right? Version of control. All right, that's a side discussion. Grab me in the hallway. We're going to talk about that. No one's going to rush the stage. Okay, cool. If you're in the IOC, I'm happy for you. Okay, that's all I have. 15 seconds left. Thank you so much for joining me at the end of the day. Really, really appreciate it. If you want to talk to me, grab me out there, or yell at me on Twitter or whatever. I'd love to interact with all of you. Thank you so much for joining me. Really appreciate it.